All right, today we're going to power up your C++ skills. We're diving deep into three core concepts that really separate the good code from the great code: templates, exceptions, and the absolutely incredible standard template library.
So let's just jump right in, shall we? I mean, if you've ever found yourself copying and pasting a function just to change one little data type, you know exactly what this feels like. It's a total pain, right? Well, C++ has a seriously elegant way to solve this.
All right, let's really break this down. See, duplicating your code isn't just kind of annoying, it's a nightmare to maintain, and it just opens the door for all sorts of bugs.
Okay, so picture this. You write a nice, simple function. It adds 2 integers. It's clean, it works, no problems at all. So far, so good.
But of course, things are never that simple, right? Now your project needs to add floating point numbers. So what do? You copy the function and you just swap int for float. Same exact logic.
And you guessed it, it doesn't stop there. Now you need it for doubles, so you write it a third time. The structure, the logic, it is identical. The only thing changing is the type.
So here's the deal. We're breaking one of the golden rules of programming. Don't repeat yourself. Think about it. If you find a bug or need to change the logic, you now have to track down and fix it in every single copy. There's just got to be a smarter way.
Well, the good news is there is a better way. It's a C++ feature called templates, and they are like the superhero designed specifically to rescue us from this copy-paste mess.
Think of a template like a blueprint for your code. You write the function or class one time using a generic placeholder instead of a specific data type. Then, whenever you use it, the compiler steps in and automatically builds the version you need, whether it's for an int, a string, you name it.
I mean, just look at this. It shows the difference perfectly. On the left, you've got all these different declarations for what is essentially the same function. But on the right, just one. That single, clean template replaces all of that clutter. It's so much easier to read and maintain.
Okay, I know the syntax can look a little scary at first, but trust me, it's way simpler than it seems. First, you just start with the keyword template. Then, you declare a placeholder for a type. We're calling it t here, but honestly, you could call it whatever you want. And then, you just use t in your function like it was any other type. That's it.
And get this incredible power isn't just for functions. You can create entire class templates. This means you can design a generic list, a generic queue, any data structure you can think of, and then create a specific version for any data type you need with just one simple line of code.
All right, so our code is flexible, it's reusable, we're feeling pretty good, right? But what happens when things go wrong while the program is actually running? Because, code doesn't always play by the rules.
I mean, think about it. What if a user enters a 0 where they shouldn't? An operation like division by 0 is impossible. And if your program tries to do it, it crashes. Your program just dies. Game over. That's called an abnormal termination.
But we don't have to just let our programs crash and burn like that. We can use something called exception handling. It's a system that lets us spot these errors as they happen in real time and handle them gracefully so the whole program doesn't come to a screeching halt.
The way it works is with 3 key players: try, throw, and catch. Think of it like a safety net. You put any risky code inside a try block. If something goes wrong in there, you throw an exception. Basically, you send up a flare that says, "Houston, we have a problem." And somewhere else, a catch block is waiting to, catch that flare and deal with the issue.
Okay, so let's recap. We've got reusable code thanks to templates. We've got safe, robust code thanks to exceptions. Now, when you put these 2 amazing ideas together, man, that's where the magic really happens. You unlock the standard template library, or the STL. This thing is a game changer. It's this huge, professionally built, super optimized library of tools that comes built right into C++. And it uses templates to give us all these generic, ready-to-use data structures and algorithms right out of the box.
So, how does this whole thing work? Well, the STL is really built on 3 main parts that all play together perfectly. You've got containers to hold your data, algorithms to process that data, and iterators, which are the bridge connecting the two.
First, you have your containers. These are basically just what they sound like. They're objects designed to hold your data. You have sequence containers like vector, which is kind of like a smart, flexible array. You've got associative ones like map for key-value pairs, and even derived ones like stack and queue.
Then you've got algorithms. These are all the workhorse functions that do stuff to your data. Sorting, searching, counting, you name it. And the best part is the abstraction.
You don't have to write your own sorting algorithm ever again. You just call the STL's sort, and it handles everything, and it does it way more efficiently than most of us could write ourselves.
And what connects those containers and algorithms? That's where iterators come in. They're the secret sauce, the glue that holds this whole system together. An iterator is basically a smart pointer that knows how to move through a container. Algorithms don't care what kind of container you're using. They just need iterators to tell them where to start and where to stop. It's what makes the whole thing so incredibly flexible.
So when you step back and look at the big picture, it all just clicks, right? You've got templates for reusable code, exceptions for safe code, and the STL giving you this powerful professional toolkit. When you master these, you're not just writing C++ anymore. You're using it to its absolute fullest to build efficient, robust, modern software. So the only question left is, what are you going to build with it?